Hey everyone, Joseph here with LogiDraft. As an electrical engineer, I've spent a lot of time coordinating control panel changes that should have been automatic. Things like increasing motor count or updating motor voltage can have cascading effects. Load, transformer sizing, and protection all must be updated in the drawing. Traditional CAD stores geometry. It doesn't store intent. Let me show you what happens when intent becomes executable. This is the canonical motor control panel example. At the core of this layout is a structured top-level block definition. By combining nested blocks and governing logic into a single assembly, it encodes engineering intent. Inputs, like motor quantity and voltage, drive how that structure behaves. What you're looking at here is a block reference placed into the drawing. The definition defines the behavior, while the reference executes it. Block references live on sheets, and a document can have multiple sheets. Now, let's take a deeper look at our example, then we'll make some changes and watch them update. For instance, here is our incoming power terminals. Here is our output voltage to our motor. Here is our control transformer and controls configuration. Now, in traditional CAD workflows, one design change or variation can call for multiple manual updates. For instance, say we wanted to change motor voltage or quantity for our panel. This can affect our control configuration, transformer sizing, and subsequent fuse sizing. In LogiDraft, these rules can be integrated into the block. Right now, this is set for one motor. I'm going to update it to 2. As you can see, the geometry instantly updates for another set of terminals and contactor for the second motor, updates our control configuration accordingly. But notice deeper, we also updated our transformer sizing and the subsequent fuse sizing. All of this was one update, and it had cascading effects. Let's change something else. We update our motor voltage, we see the same cascading effects. Our control transformer size updates, and so does the subsequent fuse sizing. Now, just to see the last two. In LogiDraft, we're not editing drawings, we're updating inputs, and the model recalculates the full chain predictably. All of the rules live inside the block definition. The block references are just specific configurations of that definition. Say I need another motor control panel. I would just copy this reference, set the new inputs, and watch as this instance updates independently. Same definition, different configuration, no additional drafting required. Now, let's look at the source. Here's where the logic lives. States, formulas, and tables drive everything, all inside the definition. Blocks are hierarchical. Parent values drive nested definitions. For instance, the transformer is its own definition, the contactor is their own definition, and the control configuration its own definition. Each layer defines behavior. Those layers stack. LogiDraft doesn't just store geometry. It stores parametric intent. Change the inputs, the model recalculates. Reuse the definition, configure each instance independently. If you build repeatable engineered systems, electrical, mechanical, or fabrication, this changes how drawings are produced.